All right, so this week we're going to go back to looking at what's called solving triangles. We've done it before. The kind of problems that we looked at before looked like this. They were always this kind of triangle. Somebody tell me, what kind of triangle is that? Yeah.
Right.
Yeah, it's a right triangle. So one thing that you always know about it is you had a 90, and things like Pythagorean theorem can be used in right triangles. And we had three different trig functions. Sine was like opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Well, this week we're going to look at triangles like that. In that kind of triangle, there's no 90. Because there is no 90, it means that there is no hypotenuse. Hypotenuse has to be across from the 90. Well, if you don't have a hypotenuse in a triangle, you cannot use Pythagorean theorem to solve it. You also can't use trig functions like opposite over hypotenuse and adjacent over hypotenuse because there's no hypotenuse. So how are we going to figure out how long these sides are and how big the three angles are? This week, that's what the law of sine is going to show you how to do. So if none of your angles in a triangle are 90, then that's called an oblique triangle. If none of the angles in a triangle are 90, then that's called an oblique triangle. We're not really going to be sketching things to scale, but if you want to visualize how can you have a triangle without a 90, there's really two ways you can do it. You can either have a triangle where you have an angle bigger than 90, that'd be like an obtuse triangle, or you can have a triangle where all the angles are smaller than 90. An example of that kind of triangle, think of like an equilateral triangle. All the angles are 60. They're all smaller than 90. But regardless of how it would look when you sketch it, that doesn't really matter. What matters is how we use this law to find the lengths of the sides of the angles. So what we like to do first is when you have a triangle, we like to label it. We like to have names for the angles and the sides. Does anybody remember from a couple weeks ago, what do we normally use for the labels for the three sides? Anyone remember? We use these in a formula too that's about right triangles, yeah?
A, B, C.
Yeah, we generally use A, B, and C as the names of the three sides. And then for angles, we use Greek letters. Does anybody remember the Greek letter that we always put across from A? Yep.
Alpha.
Alpha. Good. How about the Greek letter we put across from B? Yep.
Beta.
Beta. And last week, that's all you needed because the third angle, the one across from C, was always a 90. This week, it's not a 90. So we have to give it a name. So we still have A, B, and C for the sides. We still have A across from alpha. Still have B across from beta. But now we're going to have C, not across from a right angle, we're going to have it across from this. That's gamma. G-A-M-M-A. Gamma. So there's 6 pieces of information that you have to find here. 3 sides, 3 angles. In order to figure out the 3 sides and the 3 angles, I have to give you some information. In fact, I got to give you half the information. So out of the 6 things, I'm going to tell you 3 of them. Now, depending what 3 things I tell you, it's going to control how you figure this out. There's 5 different cases that you could have. We're going to study, those are the 5 things we're going to study all week. We're going to end up looking at 3 of them today. One of them we're not going to quite finish, and we'll finish it tomorrow. And then Wednesday we'll look at 2 more. So that's going to be 5. just write these down. Those three letters stand for the information that you're being given in the problem and the placement, where it is. If I give you a problem with an angle, and a side, that could look something like this. Make a triangle. Let me say, put an angle here, put an angle here, and a side. Okay, right there. That's an example of angle, side. You know two of the angles, and you know a side, but the side that you know is not between the two angles. It's outside of the angles. In this diagram, the side that's between the angles is the left side over here. It connects them. This is an example where the side is not between the two angles. Okay, so that's angle, side. If I did it like this, let's say this was, I don't know, 13. Now that's angle, side, angle. Because you know an angle, a side, and an angle, but this time the side that you know is the one that connects the two angles. So that's angle, side, angle. And then, let's see, I have some space. Just try to put this one down here. I didn't have room to draw all three, but hopefully you got the first one. If not, I can draw it. And side angle is when you would have something like this. Let's say we've got a side, another side, and an angle not between the two sides. That'd be SAS. This is SSA. So let's do it an angle like this. We have a side, and an angle that's not between the two sides. The lower right is the angle that's where the two sides meet. This angle is not between the two S's. It's outside. These three types that I just wrote down, those are the three types of problems that we're going to study for today. And they're the three types of problems that you can use for law of sines. The other two types, which I'm not even going to write anything down about today, are side. I'm going to do that on Wednesday. And side, angle, side. SAS. The reason we're not doing those two is because they don't work with this one. It's impossible. Oh, did I have the diagram? Oh, I have the diagrams right here. So this is basically what I just told you. So we're going to solve problems when you're being given two angles and a side. Here's some more pictures if you want to copy down some extra pictures. On the left is an example of angle, side, angle. On the right, side angle. With this one, obviously, if you say ASA forward or backwards, it's the same. So it doesn't matter. This one, if you say angle, side, that's fine. The point is you know two angles and you know a side that's not between them. So you could say it either way. This case, we'll leave the letters in that order. It's not nice to write them that way. I got one side. Okay, so we'll just leave it as side angle. But any one of these three problems, by the end of Tuesday, hopefully you'll know how to solve it. Now, what do we know about all the angles in a triangle? Right, they all add up to 180. So, even though we're not solving triangles with a 90, that's still true. They all still have to add up to 180. So, any of those three types of problems, we're going to do with the law of sines. So, I'm going to try to show you what the law of sines is, and then we'll do, after I show you what it is, we'll do three examples. We'll do one of each type. So let's see what the law of sine is. It ends up being two fractions. That's what the law of sine is. All right, so let's take a look at that picture. I didn't label every side and every angle in that picture because I'm not going to use every side and every angle. I'm labeling what I need. I didn't label side C or gamma. That's fine. Okay, I'm going to take a line from this top vertex and draw it straight down. What do you call that line that I just clicked? Well, I should be more specific. It's technically not a line. It would be a line segment. But in the triangle, that line segment is something about the triangle. Yeah? It's the height. You can call it the height. If you want to get fancy, you can call it an altitude. But it's a line drawn from the vertex perpendicular to the base. So that's the height. How do we know it's perpendicular? Well, put that little symbol. Since it's a height, I'm going to call it h. Just don't get h confused with hypotenuse. It's not a hypotenuse. And I guess you could use a different letter, but let's stick with h. Now, what I'm going to do is I'm going to look at this diagram in two pieces. I'm going to cover up the right side, and I'm just going to look at the triangle on the left. Because what I've created now is two right triangles. What I want to do is create a formula for the height involving these three things. On the left, that's a right triangle. So these two sides have names. Or better term, they have positions. What's the position of side H relative to alpha? Yeah, that's what we call the opposite side. And what about side B? That's your hypotenuse. Good. Out of the three trig functions, sine, cosine, and tangent, one of them has these two in it, opposite and hypotenuse. Which one is that? Cosine would be adjacent and hypotenuse. The first one. So it's sine. So what we're going to do is write down an equation that uses sine. Remember, when you write a trig function, it always looks something like that. You have an argument that you're plugging into your sine function, and then you have two sides on the other side. What am I taking the sine of in that picture? Which one of the three things goes right here? Well, it's one of the three things that's circled.
Yeah.
Yeah. Can you just describe where it is?
The angle.
The angle, yeah. Does anybody remember what angle that is? Well, we don't know the number, but I'm just looking for the name. Yeah, that's alpha. So the sine of alpha equals, and what would go on the other side? End up being what? Over what? Yeah. Opposite over hypotenuse. So in this case, what's opposite? And what's the hypotenuse? B. Now, when we started, I told you my goal was to get a formula for h. So I'd like to have a formula with h by itself. Why I want to get h by itself, you'll see why in a minute. 2 minutes. So how do we get h by itself in this formula? What would you have to do on both sides? Do what? Yeah, multiply both sides by b. That's gone. And now you've got a formula to find the height. You'd have to know b and you'd have to know alpha, but as long as you knew those two things, you could find the height. B sine alpha. Any questions on that formula? I'm going to do the same thing again. I'm going to do it on the other side of the triangle, on the right side. Okay, let's look at the right side. I want to come up with a formula again for finding the height, but this time I want to use those three things. So, Kiana, what's my angle that I'm using as my reference point on the right side? So the reference angle has to be one of your acute angles. Yep, beta. And what would be the position of this side relative to beta? Yep. Good. That side's opposite. And Cameron, what about side A? Yep, that's your hypotenuse. And we just have to think of the trig function. We just used it. Which trig function has opposite and hypotenuse in it? Sine. So set up your trig function, leaving 3 blanks, just like we always do for a trig function. And Grady, what's my angle that I'm taking the sine of in this picture? Beta. And I need to know what would go on the other side. Sam, what would go on the other side?
Opposite over hypotenuse.
Yep.
So that'd be h over a.
Perfect. And lastly, can you tell me what you would have if you get the h by itself?
A sin beta.
A sine
beta.
beta. So now we have another formula for h. Any question on that one? Okay, so now let's look at the whole thing. Just call this one box 1 and box 2. Box 1 is a formula that gives you the height of that triangle. Box 2 is a formula that gives you the height of that triangle. So, what do you know about box 1 and box 2? They're the same thing. They're 2 different ways of finding the same thing in that triangle. So we know that box 1 and box 2 are equal. Well, write that down. This equals this. Those 2 things have to be equal to each other because they both calculate the height. And the last thing to make this look like the law of sines is we want to put the A over with alpha, and I want to put the B over with beta. So I just want to move a couple things around. How would I move this A so it's over on the left side? Yeah.
Right by sine.
Remember, you're moving this.
Oh, move the A.
Move the A. Just to the left side.
Oh, divide by.
Yep. So divide each side by A. And how about if I want to put the B on the right? How would I move that? So?
I divide B.
Yeah. So basically, we're going to divide each side by A times B. You do that on the left, the B's cancel. And when you do that on the right, the A's cancel. So you end up with this. Sine of alpha over A equals sine of beta over B. And that is the law of sines. I told you it would be two fractions equal to each other. What's that? This is going to be a calculation to figure out any one of these things that you don't know. You can use it if you don't know A, B, alpha, or beta, but you need to know the other three. So you need to know 3 out of 4 of the things in this proportion to find the one that you don't know. Now, there is one more fraction that it's equal to. We didn't prove this last fraction, but can anybody guess what the third fraction would be based on the pattern of the first two?
Sine gamma over C.
Yep, sine gamma over C. So the idea with the law of sines is you have 3 different fractions. You only use 2 at a time. You either can use the first 2, you can use the last 2, or you can use the first one and the last one. But you only use 2 at a time. Which 2 you use depends on what you're trying to find and what you already know. So sketching is going to be helpful. We're going to try to draw something so we can figure out what is across from what. Eventually, if you do enough of them, you probably can do it in your head, visualize what's where. And the other thing is, remember all the angles in a triangle add up to 180 degrees, which we already said. Okay. As far as really explaining and giving you formulas, that's it. Now we're just going to do 3 examples for each type of triangle I mentioned earlier. Does anybody need to copy anything else, especially the stuff that you can see on the screen right now? All right, so let's start out with this one. Okay, so we've got 3 pieces of information. Alpha is 40, beta is 60, and A is 4. We're going to do 2 things with that. First thing we're going to do is we're going to make a table, which I've already done. There's your table. I've put boxes around everything we don't know. By the time we're done, we need a number in each one of these boxes. This problem would count as 3 different answers on the test. So depending on how many you get right, well, you could get partial credit for 1, 2, or all 3 of them if you get them all. Okay, and besides making a table, what's the other thing I said we were going to do? Yep, we're going to sketch it. Because we need to figure out, is this problem one of these 3? If it is, we're going to use law of sines. So obviously it's going to be. But on the test, I'm going to mix together the law of sines and law of cosine problems. You don't know which ones are which. So the first thing is draw a sketch and see if it's one of those 3. And how are you going to do your sketch? Just like that. Draw that exact picture, but just erase the 3 things that you know and fill in the numbers. Okay. And again, I don't care if this is drawn to scale. That's not what I'm going for. I just want to know what information is where. That's all. So A across from alpha. B I don't know, but that's going to go across from beta. And C I don't know, gamma I don't know. Fix that. All right, so based on the information there, can somebody describe to me what kind of triangle this is using 3 letters?
Oblique. Obtuse.
3 letters. Yep.
Angle, side,
Angle, side, angle. I agree. It is 2 angles and a side, but is the side I gave you the one that connects the 2 angles? What side connects the 2 angles in that picture?
C.
C. So for it to be angle, side, angle, you would need to know C. So right letters, wrong order. Anyone else? Yep. Angle, angle, side. Yep. You've got 2 angles and you've got a side, but the side that you know is not between the 2 angles. Whether you write AAS or SAA, that's fine. But either way, that type of problem is law of sides. Okay. So let's start to solve it.
The last angle's 80.
How come?
Because 60, 40, 100.
Yeah, they all have to add up to 180. And you already know 2 of them, so you can easily get the 3rd one. You don't need law of sines or anything fancy to get that 3rd. So that's 100. So now we're down to just finding B and C. Doesn't matter which one you do next. You can do either one. So let's do B. To find something using the law of sines, when you look at your table, you have to use a full row and a partial row. Because the 2 rows you pick have to have 3 out of 4 of the numbers in them. Yeah.
I'm confused why it's 100.
Oh, it's why, yeah, 80. 40 and 60 add up to 100. I think you said 80. Yeah. 40 and 60 is 100 plus 80 is 180. I think. Now, that's actually a good thing, because now I can kind of show you something. This angle is going to have nothing to do with B. So even though I had this wrong originally, I could have still gotten B right, but I would have gotten C wrong. So sometimes you're going to have to use information you find to find other things. It's just the way it is. All right, let's find B. So what row here is complete, has everything in it? Which one? So which row are you looking at? Let's call them row A, B, and C. Yeah, row A, the top row. Right? You think of this as the top row, middle row, bottom row. The top row has everything in it. So that row we definitely have to use. So take the information from the top row and fill it in to this part of the law of sines. Fill in alpha, fill in A. So it's going to be sine of 40 divided by 4. Equals. Now we're trying to find B. So go back and look at the law. Find the part of the law that has B in it. We're going to use that. We're not doing anything with C in this part of the law. fill in everything you can for this one, but one thing is going to be missing, and that's the b. So sine of 60 divided by b. Okay, so now look at, that's called a proportion. Look at your proportion and make sure that in the four spots, 3 out of 4 of them are numbers, and then the last one can be a variable. Okay, does anybody remember how you solve a proportion? What do you do, Don?
Cross multiply.
You cross multiply. So you're going to do 4 times the sine of 60. Not even going to do that out. You're just going to leave it. Equals b times the sine of 40. And now the last step is just to get the b by itself. What would you do on both sides?
Divide by sine of 40.
Divide by sine 40. And divide by sine 40. And that's what we type in on the calculator. 4 sine 60 divided by sine 40. Now that's it. That's how you do the logarithms. Okay, before I type anything in, I am not graphing, so I don't have to worry about the window. You don't even need a graphing calculator, but that's what I have, so I'll use it. What do I want to make sure of on my calculator if you look at what's going on in this box? Yeah?
Make sure it's in degrees.
Want to make sure we're in degrees. We're going to do every problem in degrees this week. So just make sure that you're in degrees. I already am in degrees. Type in 4 sine 60. Make sure you close that parenthesis because we're done with the 60. And divide by sine 40. We're going to round all the answers to 3 decimal places. So we're going to put 5.389. That's the length of side B. Now, assuming we got that one right, could I use Pythagorean theorem to get C? Because I have A and I have B.
Yeah.
You get a yes and a no.
You can use it. It might not be right.
So you said I couldn't even use it. Why did you say that?
Well, unless you want to try and use it given rather than use an answer that you might be wrong on.
Okay, so there's the thought that it could be wrong, and if you use something that's wrong, you're going to get a messed up answer. Any other thoughts about Pythagorean theorem here?
I think you should still be able to use it.
What is the Pythagorean theorem?
A squared plus b squared equals c squared.
What are A, B, and C?
Sides.
Can you be more specific? Yeah.
You're not able to use it because you don't want to see it.
Well, usually that's why you use Pythagorean theorem, because you don't know one out of the two. So, no, that's not why. Yeah?
Can't you only use it for right triangles?
You can only use it for right triangles. So my question in asking you to be more specific, I was hoping you'd say, this is a leg, this is a leg, this is a hypotenuse. And then I was going to ask you, where's your hypotenuse here?
Yeah.
And there is none. There's no hypotenuse. Hypotenuse isn't the longest side. It's the side opposite the 90, which usually is the longest side. But we don't have a 90, so we don't have a hypotenuse. So you can't use this at all. If this was 90, then you could. But you can't. So you're going to find C exactly the same way you found B. Do law of sines one more time. Okay, when you set it up, it's going to look like a proportion again. Now we can get into a little bit about what you guys kind of mentioned a couple minutes ago. We need to pick a row here that has everything in it. I have 2 rows. Which one should I use? Yeah. Right. We should always use the one that's given. Sine of 40 over 4. Equals. And now we're trying to find C. So what would I put on the other side? Sine of what? Sine of 80 over C. Yep. And what's the name of the thing we do to solve for C? Cross multiply. If you can do the cross multiply step in your head, that's fine. It's going to end up being that times that divided by sine 40. You always have to divide by the one that's on the diagonal with the letter. That's what always ends up happening. But if you want to write it out, you just write it out. So it's 4 sine 80 divided by the one that's on the diagonal with the letter, sine 40. And there's nothing you can do to like reduce this. You just have to type it in the way it is. Don't try to like say, oh, 80 divided by 40 is 2. Can't do anything with that. Okay. So if you're using a graphing calculator, because a lot of these numbers are repetitive, if you press second enter, it'll just bring up the last thing you typed in. And you can just change the one number you need to. So mine is now 4 sine 80. And now I don't have to retype the whole thing. So 6.128. Since this is a triangle, the biggest side should always be with the biggest angle. The smallest side should be with the smallest angle. So we can just check that quick. Bless you. 6.1, that's the biggest side. That's with the biggest angle. 4 is the smallest side, and 40 is the smallest angle. And you can't really take any shortcut, like if you say, oh, well, this angle is double this angle, so then that means this side is twice as big as that side. No way. That doesn't work that way at all. I can kind of see why you might try something like that, but you have to figure these out, just like I should. And that's it. That's a law. That whole thing. That's a law of sines problem. That's the whole thing. Any questions on that? Yeah.
Just real quick, how do we get the 8 degrees? See, what do they call it?
How do we get gamma?
Yeah.
This?
Yeah.
So that was our first step because we knew these 2 angles added up to 100, and all 3 angles have to add up to 180. So just subtract 100 from 180. I wrote 100 originally, which was right. So let's try this one. This time they've given you the diagram, so it should be a little bit easier to figure out what type of triangle you're working with. Can anyone describe to me what kind of triangle is this? And I'm looking for 3 letters. That's angle side angle. The reason it's angle side angle is because you know 2 angles, and the side that you know is between the angles. It connects them. Angle side angle. Any questions on that? All right, so because it's ASA, that is one of the types that we use log sines for. So I've got the table. And another way you can tell that this is a law of sines problem is if you look at your table, you need to have a row that's complete, meaning you know both pieces of information. Now, you might look at this quick and say, well, wait a minute, you don't have a row here that's complete. But I either need to have a row that's complete, or I can find something easily that would make a row complete.
Find the last angle.
I can find the last angle here, and that will make this row complete. What's my last angle going to be?
105.
So 45 and 40 add up to 85. And what's 180 minus 85? Yeah,
95.
95. So to make all those add up to 180, that has to be 95. Now, very important we get this angle right. Why do you think it's so important we get this one right this time?
That's the only row that's all filled out.
Yeah, it's the only row that's all filled out. And you have to use the row that's all filled out to find everything. So this time, if you get 95 wrong, then you're going to get A wrong. And you're going to get B wrong. So you mess that one up, you mess everything up this time. The last one, like I did mess it up, I wrote 100 instead of 80. It wouldn't have messed up the whole problem. It would have messed up one thing in addition to what I wrote down was wrong. This will mess everything up. So double check that. Make sure it adds up to 180. Right. And now whether we find A or B, doesn't matter. You can do either one first. Let's do A first. So you can basically write down what I'm writing for every single law of science problem. Now you just fill it in. All right, so let's identify the row that has everything in it. Jenna, what row is that? So let's say row A, B, or C.
Wait, what was the question?
What row has everything in it?
The last one.
Yeah, the last one. Right? When row, we mean we're going left to right. So C and gamma are both known. So that's what we want to use to start. How about Ryan? Can you tell me how I would fill that information in to this part of the formula right there?
You put 95 at the top, and then 4 underneath.
Doesn't matter if you would have put that on the other side. I asked him to put it on the left, but he could have put it on the right. Right. Now we're finding A. 1, what am I going to put on this side if I want to find A?
Sine of alpha over A.
Yep, and what's alpha in this problem?
Could you just go up?
I can. Yes.
45.
45. Make sure you write it down. 45 over A. All right, so we've got 3 out of 4 of the spots in our proportion are numeric. The last one is a variable. That's good. Now we can solve it by cross multiplying. Can anybody tell me what, you don't have to give me the decimal, but just tell me like A is this times this divided by this.
A equals 4 times sine 45 over sine 95.
4 sine 45 over sine 95. You know, we'll type that in and we'll get our decimal. Since alpha is the middle angle, I would expect A to be the middle side. I don't know B yet, so we can't confirm if that's true once we find A, but once we find B, we're going to hope that A is just a little bit bigger than B. So let's get A. 4 sine 45. And if you don't close your parenthesis like I did after the 5 right here, it will come out wrong. So make sure you close that. Okay, so we get 2.839, and that's for A. 2.839. I don't know if people do rounding or what ends up happening, but sometimes on the test, somebody will get an answer of this for like 2.75. If you're going to 3 decimal places, I can't see how you would be off in the tens place by that much. Right? So that's why we're always going to 3 decimal places. So even if you accidentally did use something you rounded, which you shouldn't, 3 decimal places shouldn't mess your answer up that much. So I am going to be looking on the test that you are rounding pretty accurate. I mean, I guess if you got 2.838, I'd give you credit. But I don't even know why you'd have an 8 there. It's a 9. So just make sure you round correctly. All right, now let's find B. I'll do that down here. All right, we got 2 rows that have everything in them, row A and row C. Which one should I use to find B?
C.
Yep, we're going to use C. And the left-hand side is going to look exactly the same. Sine 95 over 4. And what's going to go on the right side if I want to find B? Sine 40 over B. Now, I didn't even mention it this time about using Pythagorean theorem, but hopefully you know you can't because you don't have a 90. You have an angle that's close to 90. So if you use Pythagorean theorem, you'd be close to right, but you'd still be wrong. So don't use Pythagorean theorem. Okay, and how about Tyler? Can you tell me what B is going to equal, and I'll type it in on the calculator?
Like the actual answer for you.
Just the calculation.
2.50. What? Like fraction. Oh,
Like what times what? What times what divided by what?
is it 4 sine over 40, then over sine 95?
4 sine 40, yep, over sine 90.
Thank God.
And because beta is a little bit bigger, I would expect that to be a little, actually no, beta is smaller, so that should be a little smaller. Maybe 2.6, 2.7, I don't know. Let's see. 4 sine 40 divided by sine 95. It's about 2.6, but we're gonna round it a little bit more than that. 2.581. All right, so solving angle side angle, very similar to angle angle side, but it's even more important you get that first angle right. You get that wrong, it's all. Okay, any question on that? Okay, the last type, our last problem, a little bit different. This is the first time that we've been given 2 sides and an angle. So you cannot just add 2 angles together and subtract from 180 like you did the first 2. You don't have 2 angles to add together. You also can't use Pythagorean theorem. If you use Pythagorean theorem, you're assuming you have a 90. I haven't solved this problem yet. I don't know if I have a 90. So you're going to have to solve it the same way we did the last 2, log sines. If you look at your diagram, A, B, alpha, side, side, angle. Side-side angle still falls under law of sines to try to do it. But this one is the worst case. It's the worst case for any kind of problem we're going to learn this week. And the reason side-side angle is kind of the most annoying case is because when you go to solve this problem, it could end up being exactly like the last two problems. You go to solve it, and everything that you don't know has one solution. Or, when you start to solve it, you could realize that everything you're missing that's not in this table, that there's two solutions. So what that would mean in a problem like this means you would have gotten 2 answers for A, 2 answers for B, 2 answers for gamma. That means there would have been 6 things you had to figure out. That's what I mean by 2 solutions. 2 numbers per box. So you either end up with 1 number per box, 2 numbers per box, or it could be the kind of problem that's no solution. That's the quickest type, because once you start to try to solve it, you realize right away you can't, and you're done. So between today and tomorrow, those are the 3 types we're going to look at. We'll try one of those 3 today. Which one do you think I'm going to do?
1.
1. All right. Well, let's see if that's the one I pick. Think about if you were teaching it, which one would make the most sense to you first, based on what we've already done. Okay, so here's the information that we were given. A, B, alpha. I just put it all on a table. Well, I'm definitely seeing a row that's full. That's my hint that it's law of sines, if you don't have a diagram. And I see a row that's completely empty, and I have no way of finding anything in that row right away. That's how I know it's the worst case. This problem is very specific about the order you have to go in. Some problems I've said, well, now you could find A or you could find B. There's no, you could do this or you could do that in this problem. You have to do this, then this, then that. There's no choices. That's what you have to find first. This is what you have to find second. And that's what you have to find third. You cannot go out of that order. It's not possible. The reason you can't do anything with this bottom row right away is because the law of sines requires a full row and a partial row. Well, that's rows 1 and 2. If you try to use the bottom row, you've got 2 variables and they're both blank. That's not going to work. Right? So let's set up law of sines, and we're going to find beta. Right. If I want to find beta, Jackson, can you tell me what I could put on the left-hand side?
For beta, you would 40 degrees.
Yeah, sine 40 degrees.
And then I'm still kind of confused by this one. So.
What? Anybody tell me what's going to go in the bottom? Yep.
3.
3. It's always the sine of the angle divided by the side that's across from it. Both across from it in the diagram and across from it in the table. That's why I set the table up the way I did. So sine 40 over 3.
Could you sine beta over 2?
You have to. Yeah, you have no other option. Sine beta over 2. I guess if your question was, could you put this on the left and put that on the right, you could. But you got to have this as one of your fractions and this is the other one. That. Okay, now cross multiply and let's see what happens. So we've got 2 sine 40. And I'm kind of taking this one step by step. I'm not doing any one like steps in my head this time. So 2 sine 40 equals 3 sine beta. How could I move something to the other side to start to get beta by itself? What could I move first? Yep, I can move the 3. And how do I move it? Divide it. So let's start with that. Okay, so now you have this. 2 sine 40 over 3 equals sine beta. Is beta by itself? No. Beta is inside the sine function. Just like if you had something like this. And I said to you, is x by itself? You'd say no. X is inside the squaring function. So if you want to get rid of the squaring function, you cancel it out with a function that's the opposite. In this case, square rooting function. Well, we need a function here that cancels out sine. And what is the name of that? We talked about that the week before we did graphing. What function cancels out sine and gives you back what you started with? Yeah? It's 2 words.
It's like
Inverse sine, yep. You have to take inverse sine. Remember that's the negative 1 on the sine? So we are not multiplying here, just to make that clear. You are taking and filling in all of this information into the inverse sine formula. And then filling in that information. Plugging it in is another way to say it, into inverse sine. Well, when you plug sine into inverse sine, it's like plugging squaring into square rooting. The two cancel each other out. And all you're left with is beta on the right. Now we're going to type in what's on the left. Don't try to get fancy and cancel anything here. You can't. You just type that whole thing in. When I type that in, one of 2 things is going to happen. I'm either going to get a number on the screen or I'm not. If I don't get a number on the screen, then either I made a mistake or this is a no solution problem. So inverse sine of 2 sine 40 divided by 3. That's how you want to type all that in. Just like that. Inverse sine 2 sine 40 divided by 3. If you don't close this parenthesis right here, then it's going to do this. We don't want the sine of 40 thirds. We want the sine of 40 and then divide by 3 after. That's different. Okay, just get rid of that. All right, so we get 25.374. So this isn't a no solution problem. I just got a solution. So the first thing I'm going to do is write that down. And notice where I'm putting it in the box. I'm putting it up higher, just in case I get a second answer. So the way this is going to work now is we're either going to get one answer in this box, one answer in that box, and one answer in that box. It's not a no solution because we already got one answer. So the rest of them cannot be no solution. Once you get an answer, you know that everything has at least one answer. Or 2 answers, 2 answers, and 2 answers. So I either have 2 more things to find, or I have 1, 2, 3, 4, 5 more things to find. So the first thing we have to do is we're not done with this box yet. We have to see if there is a second answer, what would it be? And this is how you find the second answer. So I left a lot of space because we don't need that much space, but it's still a little more work to do. So leave a couple lines. And then this is how you check if there's another answer. You're going to take the answer that you just got. It might not always be beta, it might be alpha or gamma, but the point is, take whatever answer you just got and subtract it from 180. So we had minus 25.374. 154.626. If there's another answer to this problem, that's the other answer. Don't write that in the box yet, because we don't know if that angle fits in the triangle. By fits, I mean, is it too big? It might be too big. I'm just going to write it off to the side. So now, see if it's possible to fit the number you just got, 154.626, and the angle that you were given in the same triangle. So we need to scroll back up and see what we were given. What were we given?
40.
We were given 40. Can you fit 40 and 154 in the same triangle?
No.
No. The second answer in this problem is too big. That means that there's only going to be a single number in this box, and this box. So let me scroll down and I'll write down what we just did. So if there's another answer to this problem, it was supposed to be 154.626. But we were given a 40 to start with. There's no way that you can fit 40 and 154 in the same triangle, because it adds up to more than 180. Now, if this second answer was like, it's just make up something simple, like 100, well then yes, I would have said that would have worked, because then you would have had 40 plus 100, which is not bigger than 180. So we're going to finish this one, but tomorrow we'll look at one that the second answer fits. But today it doesn't. Okay, so two questions. Any concern how I got this 154.626 or how I figured out that it was too big? You need to be able to do both of those things. And that's how you always do it every time. And this is the only case you have to worry about. You don't have to do this subtract from 180 for any of the other problems we learned today. Just this one. And the reason you have to do it is because of what you did right there. You did inverse sine. That's the first time today we've used inverse sine. That's what happened. All right, so now we know beta is 25.374. So what can I figure out next? I can figure out gamma because now I know 2 out of 3 of the angles. What do these 2 add up to? 65.374, and I can subtract that from what?
180.
Yep, so 180 minus 65.374. So gamma is 114.626. Now the last row isn't useless anymore. I have a piece of information in it. So now I can figure out the last side. And this is just going to be exactly like the first 2. Okay, so let's find C. Okay, first thing, identify a row that has everything in it. Anyone identify a row with everything in it, please. Row A, thank you. Why not row B?
Because 25 minus
Yeah, this is a messy number to work with. It's a rounded number. Let's just stick with what they gave us. So, sine of 40 divided by 3, exactly the way we started out. Now, you don't really have any choice. You have to use gamma to find C. There's no way around it. So what's going to go on the other side to find C?
Sine of 114.626
Over C. So sine 114.626 over C. And this is why I'm having you round to 3 decimal places. If you round to 3, it shouldn't throw your answer off that much. If you round to 1, yes, it will. 3, you should be good. Okay, so C equals 3 sine 114.626. And what am I going to divide by? Sine 40. So let's see what we get. 3 sine 114.626 divided by sine 40. Notice I didn't close the parenthesis after the 40. It's not really important because I don't have anything else I'm typing in. So 4.243. And that's the side-side angle case where there's one solution. Tomorrow we'll do the no solution and 2 solutions. Okay, so that's homework from 4.2. It is just odds, so make sure you don't do them all, otherwise you're going to do double problems, so you need to. That's 9 to 13, 17 to 21, and 25.